butt head to the ramp. Noon table, sorry.
Success.
Damn, son!
What the? You just kissed him.
No, didn't kiss him.
You touched. I seen it. You touched. How do you feel? You've kissed Steven.
Yeah, I did kiss you and gave it.
Courtney, he's cheating on you. Send the evidence. How do you feel?
That was violation.
That's it.
What's your name?
Okay.
Okay, so we've got here, this is a stock 720S exhaust camshaft, and this is a McLaren Senna exhaust camshaft. In the McLaren literature, the Senna uses different exhaust cams, but we don't know what is different on them exactly. It could be three things. In the literature, they say they're lighter, so we're gonna weigh them. Another thing that they mention, well, they don't really mention anything at all, but another thing that could be that's different is the duration or the lift on the lobes. So we're gonna try and measure the difference between them and see if we can find out what they change. It does more or less look the same, but let's measure the lobes straight away just by looking at them. But it looks like these have more duration. Sorry, not more duration, more lift. Basically, on a camshaft, you can measure this area of the lobe, and then you measure this area of the lobe, and then if you minus area to that area, it will give you the lift. Oh, so okay, so it's got more lift for sure. It's around 0.5 mil of a difference. I'm gonna measure them more accurately a little bit. So I'm gonna try and crunch some numbers and calculate the difference between the Senna cam and, sorry, this is the Senna cam, this is the 720 cam. The lobes are larger on the Senna. I don't know if you can make it out on the camera, and the lobes are also 0.5 millimeters bigger. So they do have more lift, and it looks like they've got more duration as well. Again, it's not, because there's no specifications that they've released about the overlap, the duration, the lift on these camshafts. We're going to try and measure the difference between the 720 and the Senna ones to see exactly what they're doing, because the McLaren Senna is the pinnacle of the 4-litre McLaren engine. That engine runs 835 horsepower in stock form with different turbos, Senna head gaskets, couple of other bits that we will talk about as well, a couple of other special Senna parts. So what obviously I'm trying to do here, McLaren have already designed an engine that is more or less the same as the 720S with a couple of parts that have been changed inside the engine. They've obviously got an unlimited budget, they've done all the testing, they know what works, they know how to get power out of the engine, so they obviously decided to use different camshafts or exhaust camshafts in the Senna for a reason, right? So now I'm going to try and find out what that reason is, and if we can use that to our advantage to make more power on the 720Ss and the 765s that we're working on. So these will be going into my own car later on this year.
So, as you can see, the intake valves are bent. They've hit the piston. Piston's broken.
some kind of butterfly. Baby, you give me midnight.
New crank. These are crank retaining end caps. So on this engine block, so we've got a couple of engine blocks here. It's in two halves, so that's the top half of the engine block, and this is the bottom half. So they're in two halves. So when you've got the crankshaft in, you don't have anything to hold the crankshaft in place. So obviously when you're building the engine and you need to turn the engine round, the crankshaft would fall out. So with this, the crankshaft doesn't fall out and it holds the crankshaft in place so you can drop the pistons and rods in comfortably. Sleeve puller. So what you've got in the McLarens is, this is a sleeve from inside the engine block of a 720. This is a steel sleeve. It's a wet liner, or a steel liner, steel sleeve, whatever you want to call it. The American term would be liner. So what these sleeves drop into the engine block here, and basically you've got a coolant jacket around it. These are replaceable sleeves. On the 720S, basically on all the 4-litre engines, they're steel sleeves. On all the 3.8-litre engines, as far as I'm aware, they're aluminium sleeves. I don't think they use steel sleeves on the 3.8-litre engines at all. So yeah, these are replaceable sleeves. You can pull them out, change them. It's a pretty cool design. You don't really see replaceable sleeves on engines anymore. This is a 3.8-litre block. We're gonna pull I want to pull one of the sleeves out just to show you guys on how this tool works. So you've got this section of the sleeve puller. Magnus Motorsports, Canadian-based company. Great guys to deal with. Got them out pretty quickly. So this will go through here. It goes in from the bottom. This is an engine block for a 3.8-litre McLaren 650S. It's getting a big build because it's he's aiming for over 1,000 horsepower. We're going to be removing the sleeves from the engine, ultrasonic cleaning the engine, putting it through a parts washer. The thing is, you can't buy these from McLaren. You can't even buy these from the race teams. So on this engine block, we're going to put steel liners in and remove the aluminium ones. Just like butter. With it. The aluminium liners, we use them in the McLaren from the MP4 all the way to the 650S, 675LT. When they changed to the 4-litre engines, they changed to steel liners. The aluminium liners have got Nikasil coating on the inside, and the steel liners have also got a Nikasil coating on the inside. If you look at McLaren literature, the reason why they used aluminium liners in the first place was to save weight. I believe it was 3 kilograms they said they saved from using aluminium liners from the steel. Four kilograms, 4.3 kilograms. By using aluminium liners in the 3.8 engines and steel liners in the 4-litre engines, McLaren saved 4.3 kilograms. Obviously, aluminium isn't as strong as steel, so they must have switched to the steel liners because of strength. That's the only reason I can think of. But as we know, McLaren are all about weight saving. Another thing, the aluminium sleeves are 4mm thick all the way through, whereas the steel sleeves, they're 4mm thick in two areas. So if you look at the sleeve, it's thicker here, thicker here. That's where it seals to the O-rings on the block, and the area where it seals to the O-rings on the block is 4mm, and otherwise 2.7, 2.8. Yeah, about 2.7. So the steel sleeves are thinner, obviously to save weight, and steel is stronger than aluminium. So obviously they can get away with the steel sleeves being thinner, as Kamal said, than aluminium sleeves. Okay guys, so we are building a 1300 horsepower McLaren 720S. Quite excited for this build because, as you know, I have a high horsepower McLaren myself, but the way this build's coming along, it's going to be even more powerful than my car, because I've learned a lot of stuff along the way, learned about parts, what works, what doesn't work. Obviously when you're building a car and everything is in the unknown, you know, you're learning a lot of things along the way. You find out what works, what doesn't, and yeah, it's a journey. So, first up, this car is getting a McLaren Senna oil pump. This oil pump they use in the 765LT and McLaren Senna. It's got slightly more flow capacity than the 720S pump and the remainder of the McLaren pumps. A McLaren Senna triple layer head gasket. McLaren switched to a triple layer head gasket. 1, 2, and 3. And I've got a stock gasket here. Stock gasket is only 2 layers. Now we assume they've done this to slightly reduce the compression ratio on the engine. The McLarens from factory run at 8.7:1 compression ratio. With the Senna head gasket, I did measure the thickness and came up with a rough calculation. I believe it drops the compression ratio down to 8.4. Again, the reason why they do this is if you look at the most powerful combustion engines on the planet that are running pump fuels, not ethanol fuels, they are at a lower compression ratio than you would expect. So they did this so they could run more boost and produce more power on standard pump fuel. So we will be running 8.4:1 compression ratio on this engine. We have McLaren Senna pistons. Now, the McLaren piston is an excellent piston. It's a really, really good piston. It's very rare in the McLaren world you see a stock piston fail. I've not seen it so far. So what they did with the Senna piston is they took the stock piston and they put a DLC coating on the wrist pin. DLC stands for diamond light coating, so you can see that's all black there. And if I pick up a stock 720 piston, so that's all silver. So that's obviously without the DLC coating. But other than that, more or less, the piston is the same. Fuel pump control module. Again, I did a previous video where I was upgrading the fueling system on my 720S to Senna twin fuel pump. So that's for that. Okay, this is something I'm really excited for. Is a McLaren Senna camshaft for the exhaust side. So this car is also going to be getting McLaren Senna camshafts. These camshafts have more duration and more lift than the 720S camshafts. They haven't been tested before on a 720 to see what the exact difference is power wise, but because they have more duration and more lift, we assume that they will make more power. We've got blanking plugs for the secondary air injection system. On the high horsepower applications, we remove the secondary air injection system. Secondary air injection is where for emissions, so when you start the car up, it pumps oxygen or it pumps fresh air into the exhaust system just to get the emissions down for MOT and blah blah blah. So these are the blanking plugs and these are the blanking plates. I have a really good contact with the McLaren racing teams, so they're able to get me these parts. We also have fresh valve stem oil seal, spark plugs, that's about it in this bag. Got fresh gaskets for the downpipes and turbos, fresh coil packs. Interesting fact, these are the same coil packs they use in the Nissan Micra and the Nissan Sentra. This is the twin fuel pump. Again, made a video on this previously, which you can see on our YouTube channel. Fresh crank seals, pretty cool. If you watched my previous video on the RS3, you will have seen that on the crank seal, we fit an upgraded crank seal on the RS3 because the upgraded crank seals have got a spring inside them just to stop crankcase pressure from blowing oil out. if you look at the McLaren factory crank seal, it comes with a spring inside it. So great crank seal, and this is usually the upgrade part that we fit, or similar to this upgrade part that we fit to RS3s. So I ran 35 psi on the standard head bolts on my car. We're going to be pushing my car to around 40 psi later on this year, but I don't believe there are any issues with the heads lifting on the McLarens on the standard head bolts, but if there are, I guess I'll find out. But for now, we are using standard head bolts. We also have intake sound generator blanking plates. So on the McLarens, we've got an intake sound generator system which connects to the cabin, and it pumps fake engine noise into the cabin. We remove that because it's just another source of a boost leak. Again, we get these from the McLaren racing teams, and I think that's about it. We've also got TTE 1300 turbos going into this car. We've sent the manifolds and the hot sides of the turbos away to get coated, so hopefully I'll be able to show you them at some point as well. We have our own connecting rods that we had manufactured for my engine, and obviously I've been testing them over the past years. They're an H-beam design. They come within 5 grams of the stock connecting rod. That's a stock rod, and that is the billet upgraded, sorry, not billet, the forged connecting rod. Bearings, we use the stock main bearings and the stock rod bearings because there's not many upgrades available for the mains or the rod bearings. The rod bearings that McLaren use are a very specific size and they're unique to the McLaren connecting rod, so there's no one that makes an upgrade for them at this time, but we're working with a supplier to have replacement rod bearings made up for us. DLC coated finger followers, these are another common failure point on the McLarens. So what happened on some McLarens is the camshaft, the camshaft sit against this area on the cylinder head, and they wear over time. When they wear over time, they wear the metal away and they damage the cam followers. So what they did on the Senna and the 765, they put a DLC coating over the finger followers. So this engine is also getting these followers. You obviously have the engine on a stand here with the sleeves removed. It's just about to go through its cleaning process and we're about to begin the build. We'll keep you updated on this build. Looking forward to this car making some serious power. It's attending a half-mile event next month, so let's see what it can do. You're probably wondering why I'm using a lot of Senna parts on this build. The thing is, the 720 engine is already such a capable engine as it is. What McLaren done on the Senna, there's a version of the Senna engine that makes 835 horsepower from the factory. So obviously when McLaren are designing an engine, they need to look at everything over a long enough period of time to make sure that it's going to last. And the thing with these parts is they've already been tested to death. McLaren don't have a budget when they're designing parts, so they design a part and they stress test and test the hell out of it. So these are already factory approved parts for the most powerful version of their 4-litre engine, which is the Senna engine. So that's why we're using a lot of the Senna parts in our engine build, just because McLaren have pretty much already pre-approved these parts. So why would you not learn from the people or use the parts from the people who actually built the engine and then upgrade it from there? So that's why obviously we're using different connecting rods, but more or less otherwise it is a Senna engine, just because these guys know what they're doing. They've already built the most powerful version of that engine and made it a production engine. So yeah,